for those that had them split up into 2 different days, and not split up for those that had them all together. Okay, so if they were split up, this would be number 1 for multiplication. All right, so yeah, if you're doing from the lab, this is like the multiplication, and this would be question number just 1. But if you're the regular class, this is just continued. So with multiplication now it gets a little different, okay? So the idea here is that we are still taking our first function, x minus 4, and we're going to multiply it by our second function, negative 4x minus 5. So the best thing to do is put them in parentheses, okay, like that. And the idea here is that this piece here is going to be multiplied by both of those, and this piece will be multiplied by both of them as well. Or you could think of it backwards, and this piece has to be multiplied by both of these, and this one by both of them as well. So basically every piece inside here is going to be multiplied by every piece inside here. Same with this one, okay, which will end up having these do the same thing. Okay, now we've got kind of a thing, not a trick, but a way that we can kind of think through it. And it's called FOIL when we're dealing with this. And we call it first, outer, inner, and last. And it's just kind of an easy way to remember the steps and how to do this. So let me rewrite this one. So we've got x minus 4 times negative 4x minus 5. Okay, and what we're doing here is basically distribution, right? Because if I took this and times it by that, we would just distribute the x, right? Same with this second piece. And that's basically what we're doing here, okay? But we're doing it in an order that this FOIL kind of just reminds us so we don't miss anything up. Miss anything or mess anything up, and kind of combine that. So the first represents the first term in each group, in each binomial, because there's 2 of them. So I'd go x times negative 4x. X times x is x squared with the negative 4 out front. Then the outer represents the 2 pieces on the outside. Okay, so that would be x times negative 5, which would be a negative 5x, or minus 5x. The inner now is the 2 pieces in the middle. Okay, I guess I forgot to draw the combining line. Okay, I've heard it called other things, but FOIL is the one that I've really used. Okay, so negative 4 times negative 4x. Negative times negative is a positive, so positive 16x. Okay, then the last would be the last pieces in each one. So negative 4 times negative 5, which would be a positive 20. And then we combine any like terms, which typically the middle ones end up being. So negative 4x squared stays. Negative 5x plus 16x is a positive 11x plus 20. And there is my new function. Okay? So that FOIL is kind of the way that I would suggest doing it for the most part. You can, I guess, if you really understand it and think of shortcuts, you could go, well, 3x times x is going to give me 3x squared. 3x times negative 3 going to give us negative 9x. Then negative 5 times x is going to be negative 5x. And then negative 5 times negative 3 is going to give us a positive 15, which basically we're doing the same thing that we did over here, just not quite so fancy looking. Combine like terms, we get 3x squared minus 14x plus 15, and there is our new function. Okay, so that's when you're dealing with ones like that you would want to use the FOIL, right, where you have 2 binomials. Okay, if you have something different like 23 and 24 and 25, makes it a little easier, doesn't it? Because now you're just going n squared plus n, h of n times g of n, which is 2n. So here I just distribute. So 2n times n squared is 2n cubed. Then 2n times n is 2n squared, right? Can't combine those. There's my result. Okay, so those ones are a lot easier to deal with, aren't they, than the other ones, because we just have to distribute. So 3a times a squared, 3a cubed, 3a times negative 3a, be a negative 9a squared. Can't do any more to that. 25, same idea. X minus 5 times 4x, 4x times x, be 4x squared, 4x times negative 5, negative 20x. But again, if we have this one with the two binomials, 4n minus 3 times n minus 3, so I do our first 4n times n, which is 4n squared, our outer, 4n times negative 3, negative 12n, our inner, negative 3 times n, negative 3n, and our last, negative 3 times negative 3, which would be a positive 9. Combine like terms, we get 4n squared minus 15n plus 9. And there is our next one. Okay? Then we just have a lot more, don't we? Okay? And then we've got some with the letters, so looks like we've got 6 with, or not letters, numbers. So these last two. So again, we can go 3t times 2t, which would be 6t squared. 3t times negative 5. And sometimes it's really good to write it out so you remember which ones you're actually dealing with. And negative 1 times 2t, which would be negative 2t. And negative 1 times negative 5, which would be positive 5. Then combine the like terms to get negative 17t, then plus 5, and 6t squared. Okay? So there's not really an easier way that I can think of to talk to you about it other than setting it up like this and doing your problems this way, because it just is kind of the easiest way to do it. Now this one, notice we're not going to be able to have any like terms, are we? Because of the way that they were written. So, but what we want to do is put the highest power first, followed by the next, then the last variable, then the constant. Okay. Now, with when we have the actual evaluate numbers, okay, we can do the same thing we were doing. 4x plus 3 times negative x, get negative 4x squared minus 3x, and then plug a 1 in there, so negative 4 times 1 squared minus 3 times 1. 1 squared is 1. Negative 4 times 1 is negative 4. 3 times 1 is 3. Negative 4 minus 3 gives us negative 7. Or this is where I think it's easier to evaluate, because then we just go g of 1 equals 4 times 1 plus 3. 4 times 1 is 4, plus 3 is 7. G of 1 equals 7. H of 1 would equal negative 1. That was easy. So then we just go 7 times negative 1, and we get negative 7. See, I think this is the case really where it's a lot easier to deal with it, especially the more complex type of problem you have, where yes, you've got to deal with all pieces. Okay, and you have to do this whole big thing right here, right? And then we're going to plug in, I believe that's 3, right? Yeah. Then we're going to plug in our 3, so 8 times 3 squared plus 2 times 3 minus 6. 3 squared is 9. 8 times 9 is 72. 2 times 3 is 6, minus 6, those cancel, we're left with 72. So it's not so bad when you know what you're doing, like me, okay? I'm able to do that pretty quick. But I think it's just a lot easier to evaluate and get your information that way. Just you're dealing with the smaller numbers generally, and then it's just a matter of going G times H, and you get your result, which is the same. So I think that way is just easier, so that's the way I'm going to do the rest of these, because that's the way I want you guys to do these ones. Okay, so G of X would be G of negative 4 equals negative 4 times negative 4 minus 1. Negative 4 times negative 4 is positive 16, minus 1 is 15. So I know G of negative 4 is 15 times, now we do H of negative 4, so negative 4 squared plus 5. So that negative is outside the x squared. So negative 4 squared is 16. Bring that negative. Negative 16 plus 5 is negative 11. So H is negative 11. So then I just have to simply go 15 times negative 11, and we get negative 165. Okay. 32, same idea. Putting in negative 1. 3 times negative 1 minus 3. 3 times negative 1 is negative 3, minus 3 is negative 6. So G of negative 1 is negative 6. Then H, negative 1 cubed, plus 5. Negative 1 cubed is still negative 1. Plus 5 gives us 4. So we've got a positive 4. Negative 6 times positive 4 is negative 24. Okay, and the last two. So 2 times 2 plus 5, which give us 10 plus 5, or 15. So f of 2 is 15. A squared would be 2 squared minus 2. 2 squared is 4, minus 2 is 2. G of 2 is 2. 15 times 2 gives us 30. And finally, 2x. 2 times negative 4 gives us negative 8 for h of negative 4. Then 3 times negative 4 plus 5 gives us negative 12 plus 5, which is negative 7. So G of negative 4 is negative 7. Negative 8 times negative 7 is a positive 56. Okay, so there's how we evaluate, combine those functions for multiplication, or add, subtract, and multiplication. Alrighty?